No.
So, shall we start? Okay. So, in the previous class, we have just started with functions. And we started with a very basic definition that function is a relation from non-empty set A to another non-empty set B such that each and every element of set A has a unique image in set B. Yes or no? Then there were few mappings of relations which can be function or which cannot be a function. Then domain of a function, the set of values of x which a function is capable of absorbing. Codomain is the entire set B and range is what the images we are getting after supplying the domain elements to the function. Fine. Then identity function, I've explained you polynomial functions. I have also told you, like in case of an odd degree polynomial, if it is linear or cubic, domain is always R, range is also always R. But in case of a quadratic even degree polynomial, any even degree polynomial like quadratic, 4th degree polynomial, range is a subset of R, not the entire R. But domain is always X belongs to R. In case of a quadratic polynomial, if it is downward opening, range is what? Range is minus infinite to minus d by 4a. And if it upward opening means coefficient of x square is positive, then range is minus d by 4a to infinite. Then we have done certain examples over it. Then range of the function, a quadratic range we have asked. Then I have explained you about the rational algebraic functions. Now the rational algebraic functions were linear by linear. Their domain is always all those x which belongs to R except the ones at which denominator is getting 0. Like in case of this, domain is R minus 1 by 3. In case of this, domain is R minus 3 by 2. In case of this, R minus 1 comma 2. Because at 1 comma 2, this denominator is getting 0. Then we have done a linear upon linear rational algebraic function. Domain is this, and this is how I have found its range. Now I will cover two more examples over it. See the question. The question is, find the domain and range of fx equals to x square minus 3x plus 2 upon x square minus 5x plus 6. Now, it look like a quadratic upon quadratic. But there is a certain different about this question. X square minus 3x. Fine. So first of all, let me tell you how do we start with this question. Say, let y equals to x square minus 3x plus 2 upon x square minus 5x plus 6. This is the question. So first of all, check if the two quadratic polynomials, can they be factorized? If they can be, do they have any common factor? So first of all, if I talk about the domain, domain is what? X belongs to R minus. Now this denominator is what? See, if I factorize the numerator, it will be x minus 1 into x minus 2. If I factorize the denominator, it will be x minus 2 into x minus 3. So domain will be what? All R except those x at which denominator is getting 0. So domain is R minus 2 comma 3. Am I clear? Am I clear?
Again.
Now you have to realize, is there any common factor which is cancelling from both numerator and denominator? Then you see, yes, we can cancel x minus 2. So now your question became y equals to x minus 1 upon x minus 3, where x is not equal to 2. Correct? Now, first of all, now in the next step, we will find its range. Find the range of this linear upon linear type. For that, write x in terms of y. So it is xy minus 3y is x minus 1. So it is x times y minus 1 is 3y minus 1. So x became what? 3y minus 1 upon y minus 1. Now from here you can see y can be anything except 1. Now here if you realize, but if x approaches to 2, your y approaches to what? Y will approach to, put x equals to 2 here. So it will be 2 minus 1 upon 2 minus 3. So y approaches to minus 1. But if x approaches to 2, y approaches to minus 1. And as x is not equal to 2, y will also be not equal to minus 1. So from its range, you are going to delete y equals to 1 because of this and y equals to minus 1 because of this. Am I correct? Have a look. This is a very good question and important also. Am I clear, everyone? Let me know. Mahesh, is it okay?
Sir, please summarize it.
Can you please be a little bit more loud?
Sir, again, sir.
Again, you want me to repeat it again?
Yes, sir.
Uh, First of all, I factorize the polynomial upon polynomial type. Then domain has been decided after this. Yes or no? Now
Yes,
you
sir.
factorize it and you realize if there is any common factor cancelling or not. There is a possibility. There is a possibility. Ha, Tanush, 2 comma 3 is this, na? This denominator can be 0 if x goes 2 and 3. So x cannot be 2 and cannot be 3. So that is why it is deleted from R. That is the domain. Understood now?
Yes, sir. Yes, sir.
Now, x minus 2 cancelled and you got this. Now see, chalo, one difference let me talk about. Had the question been only had the question been only y equals to x minus 1 upon x minus 3, then domain would have been x belongs to R minus 3 and range would have been y belongs to R minus 1. One that I have calculated here. Yes, but since you have cancelled x minus 2 from here, that means x is not equal to 2 also. So if x approaches to 2, your y approaches to minus 1. But neither x can be 2 nor y can be minus 1. Am I clear now? So because of this, 2 elements have been deleted from the range. One is 1 because of this, other is minus 1. Am I clear now?
Yes, sir.
Lakshmi, got it? Hanush, understood better?
Yes, sir.
Right. Now, write down another question. Just a moment. Now, find the domain and range of find the domain and range of y equals to x square minus x plus 1 upon x square plus x. Find the domain and range of this. Now see, first of all, with the domain point of view, what do you want? X square plus x plus 1. If you do it 0, you realize that this quadratic is having d less than 0. Means no real root. That means its denominator is never going to be 0. So domain is going to be what? X belongs to R. Fair enough? Is it okay? Now with the range point of view, for the range. First of all, again we will do it in step by step. Y equals to x square minus x plus 1 upon x square plus x plus 1. So step 1, cross multiply. So you get yx square plus xy plus y is equals to x square minus x plus 1. Then step 2, make a quadratic in x. Make a quadratic in x. So then it is yx square minus x square xy plus x plus y minus 1 equals to 0. Fine. It is y minus 1 x square y plus 1 into x plus y minus 1 equals to 0. So this is a quadratic in x. Now step 3. Do its d more than equal to 0. Because definitely x is real. So its discriminant has to be more than equal to 0. Now it is y plus 1 whole square minus 4 times y minus 1 whole square more than equal to 0. Am I correct? Now it can be simplified as y plus 1 whole square minus 2y minus 2 whole square more than equal to 0. So now it is a square minus b square. So let's do it a minus b into a plus b. So y plus 1 plus 2 y minus 2 y plus 1 minus 2y plus 2 equal to 0. So a plus b into a minus b. So it came out to be 3y minus 1 minus y plus 3 more than equal to 0. Adjust it with a negative sign. So it is 3y minus 1 into y minus 3 less than equal to 0. Now make a number line. Mark the zeros of the left side polynomial 1 by 3 and 3. Fine. So any value greater than 3, if you put into this expression, you are going to get positive. Any value which is lying between 1 by 3 and 3, say you put 1. So what is happening at 1? This is going to be 3y minus 1 positive, y minus 3 negative. So it is going to be negative. And if it is less than 3, set 0, again it is positive. So this is the region you have been looking for, 1 by 3 to 3, because it is negative in this region. So your answer is y belongs to 1 by 3. So this is how we calculate range in such kind of rational algebraic polynomials. Fine. Is it okay?
Yes, sir.
Complete quickly, have a look. If there is anything you want to ask, please do. D is discriminant balance. Discriminant more than 0 because the quadratic, we will get real values of y if x is real. So if x is real, its discriminant has to be more than equal to 0. That means that b square minus 4ac more than equal to 0. Yes or no?
Yes, sir.
That's it. Now, a next function that I'm going to cover is modulus function. Modulus function. Modulus function. Now, this is also what we call absolute value function. Absolute value function. Modulus function or absolute value function. And this function is fx equals to mod x. Fx equals to mod x. Fine. Now, what does a mod function do? It makes everything positive that comes into it. Fine. Like modulus of 2 is directly going to be 2. Modulus of 4 is going to be 4. Modulus of 0.2 will remain 0.2. Modulus of 8.1 is 8.1. So if there is a positive quantity inside the modulus, it will directly come out. That means if x is greater than 0 or even equal to 0, it will directly come out. Am I clear? But if x is negative, like inside the quantity is minus 2, then what will happen? Tell me, what is modulus of minus 2?
2.
2. And how did it become 2? It got multiplied with a negative sign, I can say so. If I talk about modulus of minus 5, it will be minus of minus 5 so that it becomes 5. Modulus of minus 7.1 will become minus of minus 7.1 so that it becomes 7.1. Means if there is a negative quantity, inside the modulus, if there is a negative quantity inside the modulus, it will come out after multiplying with a minus sign. So if x is less than 0, it is going to be minus x. Have a look quickly. Understood? Got it?
Yes, sir.
Now, So this is how modulus works. Now if I ask you fx equals to mod of x minus 2. So stay completely conceptual. If x is greater than or equal to 2, means take it like quantity inside the modulus is positive, it will come out directly, x minus 2. If x is less than 2, it will come out after multiplying with a negative sign. So if x minus 2 is greater than 0, it is directly x minus 2. If x minus 2 is less than 0, it is coming out as 2 minus x. Fine. So I can write it. If x is more than 2, even equality you can use anywhere, it is directly x minus 2. If x is less than 2, it is 2 minus x. Am I correct? So if x is more than or equal to 2, x minus 2, x is less than 2, it is 2 minus x. Now if I ask you for the graph of fx equals to mod x. So what is the graph? See, now this graph has two branches. How come two? One is while x is more than 0, other is while x is less than 0. So if x is more than 0, it will be y equals to x. If x is less than 0, it is y equals to minus x. See here, x less than 0, y equal to minus x, x more than 0, y equals to x. This is the y equals to x line if x is greater than 0. And this is the y equals to minus x line if x is less than 0. This is the graph. Am I clear? Now domain you can see, you can give any value to the modulus function. So domain is x belongs to R. Range will be what? See on the graph, if you analyze the y coordinate, y coordinate on this graph is varying from 0 to, varying from what? Y coordinate is varying from inclusive of 0 to infinite. Am I correct?
Having no negative values.
Yes, no negative value. It won't be having any negative value. Now see, there's a question. Find the domain and range of following functions. First is fx equals to 2 minus mod x. Second, fx equals to mod x upon 3 plus mod x. Third, fx equals to mod x minus 2 upon 5 minus mod x. And another fourth one, which is very special, fx equals to x upon 1 minus mod x. Fx equals to x upon 1 minus mod x. Now we will do each question one by one. See, there is no range of methods finding the range of the function. There are infinite number of methods to find range of function. Different functions might have different approaches. So it's our responsibility to understand and absorb as many approaches as we see. Got it? Like the first one. I'll do it one by one. Have a look. First is fx equals to 2 minus mod x. See, domain is definitely going to be x belongs to R. Got it? Now let's talk about range. See, this fx or y, this will be maximum when the quantity you are subtracting is minimum. This fx will be maximum while this mod x will be minimum. Now, minimum value of this mod x this fx will be maximum if this mod x will be minimum. And the minimum value of this mod x is 0. So the maximum value of range is going to be 2. Now, fx or y will be minimum when the quantity you are subtracting is maximum. So if the mod x you are subtracting, which is maximum when it reaches to infinite. So minimum is going to be minus infinite. Fine. So range is going to be minus infinite to. Understand? Now, anybody any doubt up to this point? Now, second question is y equals to mod x upon 3 plus mod x. First of all, tell me one thing. Is this denominator ever going to be 0? 3 plus mod x
No,
equals
sir.
to 0. Are we going to any real x from here? Tell me.
No, sir. We
No.
can't.
So mod x is not equal to minus 3. So that means domain is going to be what? X belongs to R. Correct? Domain is going to be X belongs to R. Now if I talk about the range, cross multiply. So 3y plus y times mod x is mod x. So mod x into y minus 1 is minus of 3y. So mod x equals to minus 3y upon y minus. Now see, this mod x is always going to be more than or equal to 0. That is the range of mod x. That means this minus 3y upon y minus 1 should also be more than or equal to 0. That means this y upon y minus 1 should be less than or equal to 0. Now you can see the zeros of the rational polynomials are 0 and 1. Any value more than 1 will make it positive. Any value between 0 to 1 will make it negative, and here also positive. So your range is from 0 to 1. 1 excluding because it is the root of the denominator. 0 including because it is the root of the numerator. So range is 0 to 1. Clear? Tell me. Once again, first of all, y given to you is mod x upon 3 plus mod x. Now, as such, we have been doing earlier. I have crossed multiply and writing mod x in terms of y. So you got mod x equals to minus 3y. Mod x equals to minus 3y upon y minus 1. Now, what is mod x? Mod x is always more than or equal to 0. That means this 3y upon y minus 1 minus 3y upon y minus 1 should also be greater than or equal to 0. That means this y upon y minus 1 should be less than or equal to 0. Am I correct? Am I correct? So this y upon y minus 1 should be less than or equal to 0. And now from there we can conclude y lies between 0 to 1. Tejaswini, understood, beta?
Yes, sir.
Very good. Now, third question in this league. This time the question you have is mod x minus 2 upon 5 minus mod x. Mod x minus 2 upon 5 minus mod x. Okay, first of all, tell me domain. Domain is what? X belongs to, yes, tell me what is the domain?
The input we give.
Yes, the input values. Quickly tell me. R minus, now see, denominator is 0. When the denominator is 0, if mod x equals to 5, x is going to be plus minus 5. So domain is going to be what? R minus minus 5 and 5. No, Mahesh, not only 5, R minus 5 and minus 5. Got it? Because it is mod in the denominator. That is why 5 and minus 5 both have to be excluded. Now for the range, what you are going to do? Cross multiply. So 5y minus mod x into y is mod x minus 2. So 5y plus 2 is mod x into y plus 1. So mod x is going to be 5y plus 2 upon y plus 1. Now see, this has to be more than equal to 0 because this is equal to mod x. Since mod x is always more than equal to 0, this 5y plus 2 upon y plus 1 has to be more than equal to 0. Now make the number line. Mark both the zeros. One is minus 1, other is minus 2 by 5. Now this wave will work like this. Got it? So your y belongs to minus infinite to minus 1, excluding union inclusive of minus 2 by 5 to infinite. And how did I decide these plus minus sign? You just put any values in between these intervals. This is your answer. Am I clear?
Yes, sir.
Now, anybody who want to ask something in this? Now, see the fourth part. Y equals to, this is very important. This is also in NCERT miscellaneous. X upon 1 minus mod x. Now, you directly cannot cross multiply and do this question because in the numerator there is x, in the denominator there is mod x. So we are stuck here. As this domain, if I talk about, domain is going to be what? X belongs to R minus those x at which denominator is getting 0, that is minus 1 and 1. Correct? But this question has to be done in two approaches. See, your y is x upon 1 minus mod x. First of all, let us make two different cases. One case is x greater than 0. Other case is x less than 0. Equality we count here. Somewhere you have to count it. I did it here. So if x is more than 0, you will write mod x as x. It will become x upon 1 minus x. If x is less than 0, you will write mod x as minus x. Your y will become x upon 1 plus x. Tell me, is it okay up to this point? Very important question. Karthik, is it fine?
Yes, sir.
Now we will do these two parts separately. Again, in both of them, write x in terms of y. So y minus xy equals to x. So x times 1 plus y is y. So x is y upon 1 plus y. It has to be greater than equal to 0 because this x is more than or equal to 0. From there you will get y is less than minus 1 or y is more than or equal to 0. Got it? Come to second part. Y plus xy is x. So x will come out to be y upon 1 minus y. It should be less than 0 because here x is less than 0. So it should be less than 0. So y upon y minus 1 greater than 0. From there you will get y belongs to minus infinite is 0, union 1 say infinite. These values you can check very easily by putting on the number line. Now you have to take union for both the cases. Now to get the union, one case is saying minus 1, 0, y is less than minus 1 and y is more than or equal to 0. Other saying y is less than 0 and more than or equals to 1. Which you see, every value of x is being counted in any one of the two intervals. So your range is y belongs to. Range is y belongs to R. Am I correct? Have a look. Very
Yes,
important
sir.
question. Yes, Lakshmi? Lakshmi, were you saying something?
No, sir.
Okay. Have a look. Quickly note down. Very important question and from the NCERT also. Now, if I ask you to find the range of y equals to mod of x minus 2 plus 2 mod x minus 3. Now see, how do we say there is also a plus x. How do we calculate their ranges and how do we manage with these kind of questions? See, if I know the graph of a function, I can find the range because if you know the graph, you can see from which point to which point y coordinate is varying on the graph. And the value of y coordinate on the graph is actually the range. Got it? Now, 2 or 3 important facts about this. This graph is going to be linear types everywhere. So wherever this graph will be, it will be of linear type because no two mod is multiplying, no x is multiplying with another x. So there is only a linear type of graph. Fine. Behavior of the graph may change at x equals to 2 or x equals to 3 because there is a mod on x minus 2, mod on x minus 3. So if the behavior will change at x equals to 2 and x equals to 3. Now I will draw the graph. Make the number line. x-axis. Mark both the zeros 2 and 3. So first of all, let us calculate y at x equals to 2. At x equals to 2, y is going to be 0 plus 2 plus 2, that is 4. So graph is passing through this point. Say this is 2, 4. Now find the value of y at x equals to 3. At x equals to 3, it is going to be 1 plus 0 plus 3. Again 4. So 3, 4 also. Now in between this interval, behavior will not change. So it will remain the way it is. Got it? I also want to know the value of function in the neighboring point. One we will check with 4. So value of y at x equals to 4 will be 4 minus 2, 2 plus 2 plus 4. That is 8. So at 4, it is going to be 4, 8. So this type of graph. Correct? Now, one more point I want, I will calculate it minus, say 1. So y at x equals to 1, it is going to be 1 plus 4, 1 minus 3, 2 to the 4 plus 1, that is 6. So at 1, it is going to be 1, 6. So graph will be of this type. Now, this is the graph of this type of functions. Now, range you can see. What is the minimum value of y on this graph? Tell me quickly.
4.
4. And maximum it is going till infinite. So, range is going to be y belongs to 4 to infinity. Understood? Have a look. Got it? Well, it has been a tough session, so I'm not going to proceed any further. Today, we will once again revise these questions only that we have done. Have a look. If anybody want to ask something about any question, do raise your hand. So first of all, I have calculated the range which we were doing as rational algebraic functions. So first question that I have covered is quadratic upon quadratic, where one factor was common in the numerator as well as in the denominator. So like the question was this, it is x minus 1 into x minus 2, denominator is x minus 2 into x minus 3. So there was x minus 2 common in both numerator and denominator. So x minus 2 cancelled, question remain x minus 1 upon x minus 3. But the domain will be r minus 2 comma 3 because 2 and 3 are the zeros of the denominator. Now your question remain x minus 1 upon x minus 3, but x is not equal to 2. If x approaches to 2, put it here, y will approach to minus 1. But neither x is 2 nor y will be minus 1. So your range will not contain -1. Got it? Now, for the remaining question, we do it the way we have been doing it. Cross multiply, write x in terms of y, and you realize y is also not equal to 1. So range became y belongs to R minus -1 and 1. Got it? Now, find the domain and range of this x square minus x plus 1 upon x square plus x plus 1. What did I do? I simply cross multiplied it. Cross multiplied with y equals to x square minus x plus 1 upon x square plus x plus 1. After cross multiplication, we made a quadratic in x. Quadratic in x. For this quadratic, do d more than equal to 0, means b square minus c more than or equal to 0. With this, you get y as 1 by 3 to 3. Have a look. Any problem with this? Got it? Now, modulus function fx equals to mod x. So if x is greater than 0, it is going to be x. If x is less than 0, it is going to be minus x. Similarly, I told you how to expand mod of x minus 2. If x is more than 2, it is x minus 2. If x is less than 2, it is 2 minus x. Graph of modulus function. Then we have done domain and range of these 4 functions. Have a look at one on it. Anybody who wants to ask any particular part, I'll explain it again. Let me know. Any one of you, if want to ask any particular part, please let me know. Karthik, clear with all 4?
Yes, sir.
Anybody for any particular part? Good. So I'm not going to talk about them once again. Okay, this question, find the range of mod x minus 2 plus twice of mod x minus 3 plus x. Understood? Okay, write down 2 or 3 homework questions. First is y equals to mod x minus 3 upon 5 minus mod x. Second is y equals to mod x minus 2. Third is y equals to 1 upon or mod x upon 1 plus x. Fourth is y equals to x square minus 1 upon x plus 1. Y equals to mod x plus thrice of mod x minus 2 plus 2x. That's it. These 5 questions will be your homework. Tomorrow, first we will talk about them, we'll discuss their answers, and then we will proceed further with the greatest integer function, fractional part function. All right. Anybody who want to ask something, any doubt? Tell me. Chaliye. Then all the best. That would be all from my side for today. And have you written the homework? Have you noted down the homework?
Yes, sir.
चलिए, थैंक यू सो मच।